I am a big advocate of practices like trunk-based development, continuous integration, and continuous delivery. I'm also a Go developer. If you're like me and you would like to know how to set up a new project in Go on GitHub with GitHub Actions, I'm going to show you how to do that. Hi, I'm Jonathan Hall, and in this video, I'll be showing you how I like to set up a brand new Go project on GitHub and GitHub Actions. Now, if you use GitLab, I have another video on the topic. You can find a link over here somewhere. You can watch that one. The content is essentially the same, just tailored for GitLab instead of GitHub and GitHub Actions. So let's get started. Now, of course, the first thing to do when you're starting a new project on GitHub is to create a project on GitHub. Head over to github.com, click the plus button in the top right corner, and then new repository. I'm going to put this one under my personal workspace. Normally, I would put it under the channel workspace, but I don't have one on GitHub because that's over on GitLab. So this will be on my personal workspace, and I'll keep it public and put a link to it so you can find it easily. And then the name of the project. I'm going to call this Skeleton. Make sure it's public. I'm not going to add a README. You can if you want to. I'm going to create my own README. I usually do that later. And I'm not going to choose a license either. You could also do that and save you a step later on, but I'm going to talk you through how to do it manually, just to be super clear. So now I'll create repository. Now I have an empty repository. Yay! I'm going to copy the link, and then I'm going to head over to my shell and do some work there. Here at my shell, the first task is, of course, to clone the new repository, which will be empty, so there won't be any files in it. Then I'll change to that directory. Here's where my new project is going to live. Now, one quick word about branch names. Git's default branch name is master. However, GitHub's default branch name is main. If you have a preference, then you may, of course, specify that manually. I'm going to go with Git's default just because I'm going to do everything manually. If you were to have initialized your project using a README on the page we just saw, that would have used GitHub's default of main. You can use whatever name you want, either of those or any other name as well, but I'm going to be using Git's default. So now to initialize our Go project, we're going to use the go mod init command. Generally speaking, you're going to do go mod init followed by the full path to your project, and that should be the fully qualified path. I'm using GitHub in this case, so it's going to start with github.com, and then it's my personal group, which is Flimsy with a Z, and then the project name I just created. You will see people using shorter versions of this without a fully qualified domain name. It does work in many circumstances, but it will cause problems in other circumstances. So best practice is to always use the fully qualified name, including github.com or gitlab.com or whatever hosting service you're using, followed by the full path to the project. Now we can see that it's created a file. We can cat that file, go.mod. It's a very simple file. We could have typed it, but the tool does it for us. I'm going to add that now to my git commit, and then I'm going to create a commit. I like to just document, when I create a commit that is completely automated, I like to document the command that automated it. It just makes it easier in the future. If you're ever reading those messages, you know that it was automated and it wasn't somebody typing those things in. Now, I'm going to run the git branch command to see what branch was created. And you'll see that it's the branch called master. As I explained a moment ago, that's because Git's default is called master. If I had created this on GitHub instead, using the README, for example, then this would be called main at this point. Now that our commit's ready, let's push it up to GitHub and hop over to the web interface again. Here on the web interface, I'm going to refresh to see what has changed. And now we see the more common view we might have of a GitHub project with a single file in it, go.mod. So now we technically have a Go module, and it's technically published on GitHub, but there's no content in it. So what's our next step? I think the next reasonable step is to create some content in that package. We're not going to be coding in this video, though. I'm going to just do the minimum necessary to say that we have some Go code and that it compiles and executes and so on. So let's head back over to the console. So I'm going to open my editor, and I'm going to use VS Code for that today. And I'm going to create a new file. One convention I like to use on many of my projects is to create a package called doc.go in the root of my project that only contains documentation, GoDoc. So it will have the package name, and then above that, a paragraph or more explaining what the package does and what it's for. I like this convention because it's a convenient way to place that package level documentation. And it really serves the purpose today because it lets me create technically a Go file that has technically code in it, but doesn't actually do anything. So it's a really great way to just demonstrate a bootstrap project. So that's what we're doing today. Let's go. There, simple enough. Single sentence, single paragraph explaining the package. In your project, of course, make it longer, make it as descriptive as necessary for your audience. Now that I have my doc.go file, let's create a commit and push it up to GitHub. I'm going to do that with a small pull request. So first, I'm going to create a branch. Then I'll create my commit. Then I'll push it up. Let's head back over to the web interface. And we'll see that we have a new branch detected, and we can create a pull request with it. I'll just use the default description here. Now, we haven't set up any rules yet to run tests or anything, so we can go ahead and merge this immediately. Now, notice this little purple box here telling us that the pull request was merged successfully and closed, and that we can delete the branch. I will go ahead and do that, but that is annoying. You've probably noticed that before on GitHub projects. We'll talk about that in a moment. Now, back in my local copy, I'm going to pull down the latest version of master, which of course has only my single change in it. Now here, it's prompting me to configure how I want to do pulls. This will happen the first time you do that on a new project. And I'm going to use the config pull ff only option. Now if I run git branch with a -- merged flag, it will show me any merged branches, which of course includes the doc branch that I had just created the pull request from. So I can delete that one locally. So now we have the absolute minimum necessary to say we have a Go package. We have a single Go file in there that is valid. Now we can run our tests. Of course, there are no tests to run. We expect that. I'm not going to be writing tests in this video either, but we will prepare this repository, this project, so that as soon as tests are added, they will be run and executed in your CI pipeline. And of course, that brings us right to the heart of this video, and that is how to set up GitHub Actions to run tests on your project. So let's do that. Now, for GitHub Actions, you're going to have a directory within your repository called .github/workflows. And within that directory, you can put various YAML files that control and define how your jobs run. So we're going to create our first job there, and I'm going to call it test, or test.yaml. Let me make that directory first, and then I'll open that file in my editor. Now, of course, that file is empty because I'm just creating it. But let's get started with that. Let's name this workflow. Call it tests. And we need to tell it when it should run. And I want it to run for all pull requests on all branches. Really, we only have a single branch here called master, so it could be any pull request on the master branch. But if you ever create other branches, if you're using, God forbid, Gitflow or something like that, you might want this on other branches as well. So this tells GitHub Actions to run this workflow on pull requests against any branch. Now we need to tell it what to do. So we're going to create our jobs definition. So let me just walk you through the steps that I've created and what each one does. The first one here, of course, called checkout, just checks out the code in the Git repository into the running container where the tests and the pipeline is running. The second one installs the specified version of Go. It's important to quote this here so it's interpreted as a string. Otherwise, it will be interpreted as a number. And newsflash, 1.20 is the same as 1.2 when it's a numerical value. And this code will not compile with Go version 1.2. So if you have a 0 in your version number in particular, it's really important to use a string value here. Just use a string all the time. Next, we download any dependencies. Of course, this particular project has no dependencies right now, but if you clone this and add to it, or in your own project, you almost certainly will have dependencies. So this is a good step to run. And then finally, this is the reason we're all here, to run the tests. The // syntax tells it to run all the tests in the current and any subdirectories, and the -race flag tells it to run the race detector, which is always good practice too. You may detect some actual serious bugs by running the race detector in your tests. So with that done, let's hop over to my terminal, and I will push this up to GitHub, and we'll go from there. GitHub has detected the new branch, so let's create the pull request. Fingers crossed, if everything worked correctly, it should be running some tests for us here shortly. All right, so here the test is running. Let's look at the details of that test. We can see it's already underway. It's in the test code stage right now. It should just take a few seconds, and it's done. If we expand the details here, we'll see it does exactly what it did on my console. It runs the test with the race detector, but there are no tests to run, so it succeeds. All right, so I can merge this and be done with this particular one. Once again, I'll delete my branch, but I'm tired of doing that. I want to make that automatic. So now we have our tests running, but they're not enforced. Now you may or may not have noticed that there was no requirement for me to run those tests before merging. Let's make that a requirement now. Click on the settings and go to branches. So I'm going to click on add branch protection rule. And I'm going to type the pattern. Of course, this is just master, or if you're using main, that's fine too. Just type in the name of the branch you want to protect. Now let's walk through each of these options, and I'll tell you which ones I like to use and why. So the first option we have here is, should we require a pull request before merging? I'm going to say yes. Most teams are going to say yes. If you're using strict trunk-based development without pull requests, of course, you would say no, but that's not really what this video is about. Require approvals. If you're on a team with other people reviewing your code, you would say yes. I'll leave that enabled. If you're on a solo project, saying yes is annoying because then you have to force override every time you want to merge something. Dismiss stale pull request approvals when new commits are pushed. I think this is good practice. Some teams don't like this, but it's very easy for a change to go unnoticed accidentally without this. So in other words, if I've created a pull request and you've approved it, and then I push some changes, you would not have to reapprove. And I might accidentally push a bug or some unintentional consequences that way. So this ensures that somebody's always looked at the latest version to approve it before merging. Require review from code owners. I'm not going to enable that here. If you're on a large team, you may configure code owners, which allow you to specify who owns which parts of what code, and then you can require review from those particular people. I'm not doing that today, but you might want to. Require approval of the most recent reviewable push. So this is whether or not the most recent reviewable push must be approved by someone other than the person who pushed it. I'm not going to do that today either. Now this is the one that's actually the most important for today's video, and that is require status checks before merging. Yes, you want to do that. This is what it forces your tests to pass before you can merge. If you don't enable this, somebody can merge code even when the tests are failing. If you're going to let your tests fail and rot like that, why have them at all? Now, a secondary related issue is whether or not your branch should be up to date before merging. To illustrate what that means, let's imagine that you've created a branch off of master and you're working on that. Meanwhile, your colleague has also created a branch off of master from the same point. Now, you're adding feature A and your colleague is adding feature B. Your colleague pushes feature B up and is merged, so now master has been updated, but you're still based off of that old version of master that doesn't have that new feature in it. By checkmarking this option, GitHub will force you to update your branch to the latest version of master before merging. This is really useful because it can prevent sort of invisible merge conflicts. we're all familiar with regular merge conflicts where I've edited one file and you've edited the same file on the same line. That's a literal merge conflict, right? But there are also invisible merge conflicts. So back to this scenario where you and your colleague are both working on features. Let's say that your feature depends on a file called foo. Let's also say that your colleague deleted that file in his branch because for some reason he thought it was obsolete. It probably was in his working copy, right? So your tests are passing because in your working copy, that foo file is there, and his tests are passing because in his working copy, the foo file has been deleted. So individually, your branches are working just fine. But if you merge them without this option, then whichever one is merged last could potentially fail, especially the one that depends on that foo file being there that has been deleted. By checking this, you ensure that that never happens. So that's why I like to do that. It is a bit annoying sometimes, though, because it does force you, especially on a busy team, to rebase or even merge your code from master into your branch frequently. But I still think it's good practice because it ensures that those sort of invisible merge conflicts cannot happen. Or if they do happen, your tests will fail and tell you about it. Now, this search for status checks option gives you sort of a brief history of status checks that have run on the repository in the last week once they have been running, and you can select which ones are required and which ones are not. That can be useful in some cases if you have multiple, say, external tools running on this. Maybe you're using SonarQube or some sort of security vulnerability checking or whatever as part of your process, and some of those rules are allowed to fail and others are not. You can fine-tune that here. For today, though, I'm only worried about running the tester, which we just created, and in a moment the linter, and we want those to both unconditionally always pass. So there's no reason to change that right now, but you might need to in the future. Moving on, require conversation resolution before merging. I think this is usually a good idea. What this basically says is that every conversation somebody creates in a pull request has to explicitly be resolved before you can merge. That's not really a very big inconvenience because usually anybody can resolve a conversation. But this just helps to make sure that you haven't accidentally forgotten to address something that somebody brought up in a code review. Required signed commit, I'm not going to do that. Your company policy may require that depending on security policies there. Require linear history. I'm not doing this here, although I do kind of like it. This basically doesn't allow you to merge code that has been merged. And that's kind of archaic and off the topic for today, so I'm not really going to go into those details. Do what your team tells you to do in that regard. Require deployments to succeed before merging. If you're using deployment environments other than production, like say you have a development deployment, for example, then you can check this. I'm not doing that for today's project. That's more advanced. Lock branch is also an advanced feature we're not talking about today, but it lets you create a branch that's read-only. We're not doing that. And then finally, an option to not allow bypassing the above settings. Without this option, anybody with administrative access on the repository can override the above settings on a per pull request basis. This prevents that. And allow force pushes and allow deletions. You should not be allowing either of these on the master branch. You might allow that on some sort of staging branch or development branch, but for a master branch, you should never allow that. So that's it. I'm going to create this rule. And so now my master branch is protected. Future pull requests, as we'll soon see, will require that the tests pass before they can be merged. Now, there's one other area we should look at in settings to set up your project well, and that is on the General tab under Settings. If we scroll down, we can see the pull requests section. Now, this is going to be fairly opinionated, but I'm going to offer my opinion and my reasoning. So when you create a pull request and you merge it, there's a few different ways that can be merged. And by default, they're all allowed, and you can select which one you want in the drop-down on the pull request merge button. I like to be more strict about that. Now, my personal preference is to always do merge commits. So I'm going to disallow squash merging, and I will disallow rebase merging. But let me explain what those are in case you're curious. Squash merging will take all of the commits in your pull request, squash them into a single commit, and merge that. I don't like that because it makes the history of that pull request difficult to read. However, if you're in the good practice of making very small pull requests that may only have a single commit anyway, then that's not really a problem. So you need to decide among your team whether or not to allow squash merging. Now, rebase merging is a little bit different, and that will take all of the commits in your pull request and rebase them on top of master. This is redundant with the option we saw on the previous screen of ensuring that your branch is up to date with master, however. So if your branch is up to date with master, which I think is good practice, then you effectively already have a rebase merge anyway. So this is not necessary. So that's why I like a merge commit option. I also like a merge commit option because it makes it easy to revert an entire commit if ever necessary. If you discover there's a bug in the new feature you've created or something like that, you can easily tell where that commit, that pull request was merged and revert the entire pull request at once. This option to always suggest updating pull request branches, I don't like doing this through the web interface. I'm in the habit of updating my working copy from master fairly habitually if my branch lasts long enough, which is doing a local git rebase. This will let you do that through the web interface if you want to, so you could check that. The reason I don't like to do it through the web interface is because it doesn't do a rebase, it does a merge. It merges from master into your branch, and I don't like merging that way. I like to merge only into master. But many people don't have that same pet peeve I do, and that's really for a different video to talk about. So you can do what you want here, but my preference is not to do this and instead do that rebasing locally. Allow auto merge is something you'll have to choose for yourself. I prefer not to do this on busy projects, although I do use it on a couple open source projects where the risk of somebody merging something is when they're not around to fix it is pretty low. But what it does is it allows you to check your pull request as auto merge, and then as soon as it's approved by somebody, it will be merged. The reason I don't like this on a busy project is because I like to be around when my code is merged so that I can detect if there's something wrong and I can do a revert or a fix on my own time. But as long as you understand what it does, you can decide how you should use that on your team. And here is the topic I've talked about a couple times already in this video: automatically delete head branches. You should almost certainly select this. This will delete your branch after you've merged, which is no longer needed anymore. So check mark that and you'll save yourself the hassle of hitting the delete button, or worse, forgetting and ending up with hundreds or thousands of stale branches sitting around that nobody needs anymore. Unless you're using Git LFS, you don't care about this. And if you are using Git LFS, you probably already know about this, so I'm going to skip over that. Here's a beta feature I've never seen before, which allows you to limit how many branches and tags can be updated in a single push. I don't think we need to deal with that. And then finally, the stuff about renaming and deleting your repo. So that's it. So really on this page, the important things are how you want to allow pull requests to happen. And my preference is merge commits only. And then automatically delete head branches. Those are really the important things on here. And the rest of it is kind of up to you how you want to handle your project. So now we have our project configured properly to ensure that our tests are run for every pull request. But our project skeleton really isn't complete yet. There's a couple missing pieces. Now, one really important thing to do, especially if you want to publish your project publicly, is add a license file. Without a proper license file, for example, pkg.go.dev will detect that your software is not open source and will not display the Go doc to people trying to read it. So this is doubly important if you want an open source project. Even if your project shouldn't be shared and isn't public, you still might want to put a license file in there that says this is not open source, do not use this code. That way it just helps to settle any doubts if anybody ever happens to find that code or it gets leaked and they discover it, then they'll know that they shouldn't be using it. But let's talk about how to add a license file. So let's create our branch here. And then I'll open up a license.md file in my text editor. Now I'm just going to copy and paste the text of the MIT license here. There we go, that should do it. Then I'll add the file and the commit message. And then we'll push upstream. Let's create the pull request. Okay, so the tests have passed on my pull request. I'm allowed to merge, so let's do that. Now, there's one last thing I really think is important to do for your continuous integration on a Go project, and that is to run a linter. A linter can help you find all sorts of bugs or style problems with your code. I have another video that goes into much more depth about that topic. There'll be a link if you're interested. But let's just jump into how to configure your linter to run in GitHub Actions. So we'll create a branch for the linter work. Now, as before, when I created the test workflow in the GitHub Actions directory, I'm going to do the same for the linter in a new file. I'm going to call it linter.yml. Now, the best linter, really the only one probably worth considering in my view, for a Go project is called Golang CI lint. It's free, it's open source, and it takes a whole bunch of other popular linters, bundles them into a single executable, and runs them more or less in parallel, so it's pretty fast. And there's already a GitHub action to do that for us, so we just need to configure it. As with before, we need a name for our workflow. We need to tell it when to run. I'm doing the same configuration I had before. So this one's pretty straightforward. I just have 2 steps in my linter job, so I'll talk about those. The first one is the same as in the previous case, where it just checks out the code. And then the second one runs the Golang CI lint action, which I can specify the version number, v1.52.2 in this case. That's the latest one as of this recording. And it just runs the linter. It's really pretty straightforward. Let's commit this and push it up and see how it goes. All right, we can see that the checks have all passed. Let's look at the details on the Golang CI lint job we just created. As expected, it does the checkout and it runs the linter. No problems found because there's no code to really test, but it does pass. Now, before I merge this, I do want to add a custom linter configuration to my repository. You will probably want to customize your linter configuration. Without doing that, it just runs the defaults, which is a good start, but you probably want to customize that. Again, the video I mentioned before about the linter talks about a good baseline configuration you can start with. I'm going to copy that configuration into this repository and use that. So I have that configuration file in my home directory, so I'm going to copy it from there. So here you can see the configuration. I'm not going to go through the details, my other videos for that purpose. Right, my linter pull request has been updated. Let's wait for these tests to run. And it's passed. I'll hit merge. The only thing I haven't added to this repo is a README, which is probably a good thing to do, so I'll add that here at the end as well. Otherwise, this project is really complete. This URL is available if you want to check it out. You can clone it. You can copy it as you wish. It has a MIT license, so you're free to do with it as you wish. And also, I want to show you, if you hop over to pkg.go.dev, you can actually see the packages available there now, and it shows that it uses an MIT license. So you can do the same thing with your own projects as long as it's publicly available, not private in GitHub, and has a license file, then it's publicly published as well. So that's really all I have to show you in this video. I will have a link to this project in the show notes if you want to clone it or read it for yourself. And that's it. I hope you found this useful. Be sure to hit the like button if so, and I hope you'll subscribe and hit the bell to be notified the next time I have some new content coming out. Until then, boldly go.